as already announced, so tomorrow we will have your first quiz. So it will be at 10. So it will start at 10. It will be around 15 minutes. It will be in CSC Moodle. So I believe that all of you are checked your Moodle login ID. If not, please check it. So at 10 we will start. Okay. The course is up to the syllabus is up to last week, last Tuesday. Okay. Let me share my presentation. Okay, so today we'll discuss about the basic structure of SQL. Rather, we'll continue our discussion tomorrow also after your that first quiz. So today we'll see that basic structure of the SQL. Incidentally, you have already started writing SQL in the lab, so you are conversant with that. But let us see formally some of the aspects, right, which may be a little basic for you or repetition. Already you did, but nevertheless, let us. So what we see, so it is in the chapter 3 of the book. So this IBM SQL language developed at the part of their IBM System R project. So it was the first thing which came into the thing. So what is the so if we just go a little back, so what we are trying to do in when we look into database management system or relational database management system more specifically, we want to structure the data in a more appropriate way so that the information insertion and retrieval from this database will be much easier, right? So SQL is the language which is used to interact with the underlying database, right? And as we see that as it follows some standard like ANSI and ISO standard, so the if you know one variant this SQL, so it is more or less same across the different vendors. Like as also you may be experiencing or will be experiencing that you are maybe doing in MySQL, and later on if you work on some other SQL servers like say Oracle. So the basic structure remains same. Though there are little bit different between some of the implementation, but nevertheless the structure remains same. So in other thing is that once we fire a SQL, it is much at the higher level or much higher abstraction. So underlining definitely on the underlining database or underlining the data which is stored in your disk, there are different algo which are being launched. So we are not going to those things. We want to see that how this SQL runs. So there are different variants starting with SQL 86, 89, 92, 1999, 1999, 2003, rather 2006, another variant is there. So commercial systems mostly offer SQL 92 features, right? And plus varying feature sets from different standard and some of the proprietary features. So what a line of person you will find in this book also that that all the things which are described may not run toto when you use other things. So if you look at that SQL language different components which already you might have encountered some of them. One is that data definition language like or DDL, right? Provides commands for defining the relational schema deleting, updating relational schema. So if we look at again from the point of view of ER diagram, so what we try to do from those, or once I do some sort of a this conceptual model, then we want to find out the relational schemas, right? So, or the structure of that relations or the tables. So that definition is the definition. So every table has represent a relation which has different attributes, or in table columns which have different domains of or the range of values the attribute can accommodate. Right. So this is the DDL, and then we have data manipulation language. The SQL DML provides the ability to query information. What we are more used to, or what you are doing, will be doing in your lab also, that this once you define that database, mostly this data manipulation language, or DML, from the database, and to insert tuples, delete tuples, modify tuples, and all those things. So whatever is required, so retrieve information, insert data, retrieve data, and things like that. Other than that, there are other things like integrity constant, how to insert, like SQL DDL includes commands for specifying integrity constant that the data stored in the database must satisfy, right? So one such is, we'll see, one such is maybe the primary key. There are constraints on the foreign keys and things like that, right? And there are other things which we will not immediately, will slowly consider. One is that view definition includes command for defining views, so I can have different views of that these schemas. Transactional control includes command for specifying beginning and end of transaction. So what we see that there are need of transactional control, like if I have multiple databases, and if there is several transactions going on, like updating, querying, updating, especially if there are things like read write type of things, where updating and reading both are involved, then I need to have a transactional control over the things, right? Like I transfer from one account a X amount to other account, and then when it will be reflected things, and that there is a transaction from in two relations or two tables, so that type of controls, who will go after whom and type of things, right? So if there are multiple transactions or on multiple tables, so those transactional control, which is pretty important. And there are things like embedded SQL or dynamic SQL that define how SQL statement can be embedded with general purpose programming language, like C, C++, Java, and other things, right? So where I can fire the SQL statement while working on some higher level things, right? So those are different aspects of this embedded and dynamic. Some part you will try to see when you do in the lab, when you we'll discuss here also, when we work on some that mini projects and type of things, or some where we developing a overall a system, like you may be used to that web-enabled database applications, where the front end is some web interface, and the back end is are there. There are other issues like authorization, like SQL DDL includes command for specifying access rights and relations to relations and views, right? Who can have authorization on which type of data sets, so that are other issues of authorizations, right? So SQL do support. So what we see, it's a rich-in feature. So not that all we are using, and but this is rich in features in managing a data sets, right, or a large database, right? So and some of the features will be looking in the some subsequent things. Some of the things we'll be using. There are other issues like concurrency control, issues of normalization, all those things will also come into play. So we'll slowly look at. So as of now, in today's class, we will be seeing that more of the basics of SQL. Most of the things might have already, some of the things might have already you've done in your assignment, lab assignment. So the first thing when we talk about this DDL allows specification of information about the relations, like the schema of each relation, right? What are the schema of each relation, right? Like I say, student, so the schema contains student roll number, name, maybe the name, like it is BTech, dual, MTech, PhD, MS, and etc. It can have other things like some hall ID related to a departmental ID where it is you are attached to, right? So domain of the values associated with each attributes, that is important. Like what are the domain of the values? So if I say a roll number, what should be the range of the things the roll number can take? Even if we look at other attribute sets, what are the? There are definitely integrated integrity constraints like the primary key, foreign key, and things like that. Not null type of things. Like I can say student name cannot be null. So, and what we'll see later on, also information such as set of indices to be maintained for each relation, security and authorization information for each relations, physical storage structure of each relations on the disk, that some of the things which it may have, that we'll see later on. So when we talk about the domain types, you may be using while defining your data types in this MySQL database. Like one is the character n, which is a fixed length character, right? With user specification of length n. There is a varchar, variable length character, with user specified maximum length n. Like if I say character n equal to say 20, so even if you say write something like Kharagpur, so the text will be as a will be blank. So it is fixed as character of 20. But whereas in the variable length thing, so max you define as 20, but if it is Kharagpur, so much length will be there. So in some cases, so if you try to compare in some implementation, it may show a mismatch or false, that if you equate that this once something defined as a char and varchar, but usually it will take care of this blank sentence. So integer, similarly, that integer, small int based on the machine dependent, so small int thing, and there are other things like numeric, PD, that is P is the digit along with that initial sign, whether it is a positive or negative, and D digit is the number of decimal points, right? So like represented by this 44.5. So it is and for this type of, if I say numeric 3 1, where that first one is reserved for whether it is a minus or plus, right? In case of plus we are not specifying positive, otherwise negative. And similarly double real double precision, floating number with user specified precision. And there are a few more domain types, something what we will look into subsequent lectures. Okay. So these are the different domain types when you try to define this different that by using this DDL, right? Provides for when relational schema, etc. you want to define or modify. So when we want to have a construct a table, so the thing is that create table R and E1, D1, E2, D2, and so forth with integrity constant, etc. Like where R is the name of the relation, like I say, create table student, and like ID or roll number is say character say 6 or 7, and then name as varchar, department name varchar, and the student may have phone number, may not be the salary, which may not be appropriate, and phone number, which is a int type integer of size something, uh, 8 or 10 something. So each this attribute name as a schema R, and D1 is the data type of the domain attribute, right? So these are the things which are there when we talk about this mm, creating the table. So I create the table, or basically create the relations like this. Okay. Now there are some of the integrity constant which are there. So like one is the not null. Like I can say, like in this case, instructor, the instructor ID char 5, instructor name varchar 20, department name varchar 20, and salary something. I can say that name varchar 20 not null. That means instructor must be specified a name. ID may be a primary key. I specify the ID as a primary key. By default, that it will not allow the primary key to be null. So by default, it will so not allow primary key to be null, and primary key should be unique. So like here, right? So we have primary key. We can have foreign key. Like in this case, ID equal to create table instructor ID equal to character 5, name varchar 20 not learned, department name varchar 20, salary, and then we define the primary key as a ID. Like in this case, if the so ID is the, or the instructor ID is the primary key, and the foreign key as the department name, which refers to the department. So there is a department name in the department table, which is the primary key there, and here we define at the department name. So the primary key declaration in a attribute automatically ensures it is a not null. That means primary key should be not null, and ideally the primary key should be unique. That means there will not be any repetition of this primary key in the tuples. Right? So this is the way we declare this a table. Already you might have already declared, and some of the database systems they will provide you interface to declare the table in a appropriate way. So you declare this primary key and things like that. So otherwise I can do always in a command prompt. So similarly, create table student where student name is not null. Here also student ID is the primary key, and here department name refers to department. There can be create table text. So that is which has a ID, and course ID this where care, and this code ID as where care, section ID, semester, and things like that. Here the primary key is ID, course ID, section ID, semester, and year. Right. So where is ID is a student takes some courses, right? So the ID and course ID, section ID, and there are years. So here we can have rather this. If you see, the primary key is constructed not based on the ID but based on the ID, course ID, section ID, semester, year, so that it specifies a student takes some courses in a particular semester and things like that. Right. So rather the foreign key here ID refers to the student. That means the ID is a primary key in the student, and foreign key course ID, section ID, semester refers to the section. So it is brought from the this whole thing from the section thing, which is there in the section table. So one thing, one note, if you see the section ID can be dropped from the primary key above to ensure the student cannot register for more than 2 sections at the same course in the same semester. If it is the section ID as the primary key, so I can have same student, same course ID, same semester, same year, 2 sections, will be a distinct two tuples in the text relation. So in other sense, if we try to find out the meaning of the things, a student can register for a particular course and in two sections. So if we do not allow, so the section ID can be dropped. What we mean to say here, that while choosing that what should be the primary key and how things, so you need to keep in mind that what sort of operations you are trying to do, right? What are the things is allowed in your system or in real like what is allowed in the your real life operation of the systems and vis-a-vis the database. So as such, what we are trying to, when we develop this relational database or any database management model, we are trying to basically make a information or a backend of the information system which cater to this real life situation. Like in this case, we are trying to look at course allocations and things like that. And that should appropriately back. Like we don't allow a student to be member or a student of two sections, right? So similarly, in case of a course, so course has a course ID and so forth. Here also we can say course name, course title, varchar 50 not null. That means putting a constant that there should be a course name. Even the course should belong to a department. I can so that's why the department name refers to a department thing, and course may have a credit, right? So course should ideally should have a credit, right? So we specify those things, right? There can be like different other features, like I can say the course ID may indicate, and I can say the type of course, like whether it is a UG course, PG course, and things like that, right? Interdisciplinary course and things like that. So similarly, we have sections which have, these are the features where this section is of a particular course. So we have this course ID referring to the course, and course ID, section ID, and semester and year may be the primary. So so this the how you design and what the how you design the table, it basically comes from that how you have prepared that initial conceptual model by looking at that real life operations, and which you might have drawn that ER diagram and then coming to the. So if you look at our lab assignments also, it is basically having a what we are telling that from this ER diagram you prepare, then you come to this construction of this table structure, and then you are firing queries and things like that, right? Okay. So if we so if we see other things, so one is now one is that creation of the table. The other things that updating the table, like you can do insert into in a go like this, insert into instructor values and the series of values which are having a back to back with the sequence what is there. So ID, name, department name, salary. Same way, ID, name, department name, salary. You can remove all tuples from the student relation, delete from student, it will remove all tuples from the student relation. You can drop a table, like drop table R, right? So dropping a table from a particular database schema. And then you can alter table R, add A to D, where say attribute A is the name of the attribute to be added to the relation R, and D is the domain of A, right? All existing tuple in the relation are assigned null as the value for the new attribute. So if nothing is added, if as no as a new column or new attribute, so all the by default all will be assigned as a null, right? So which will be populated either through running some SQL or through some other process, right? So alter table are drop A. So you want to drop a particular column where A is the name of the attribute in the relation R. But dropping of attributes, many database systems may not support that dropping of attributes, right? That one main reason may be there may be a lot of other relations which are associated with this. So the overall the dropping of the attribute may make the whole system unstable. Right. So some of the databases systems may not allow this dropping a particular column or a set of columns from the attribute set. Right. So that may not be allowed by the database system. Okay. So what we see that we can insert in the things, delete, drop, and alter. Right. So you might have already inserted data into your database in the lab. So typical SQL query has of the form select so from so and so where some predicate P, right? So A is the represents these attributes, right? Which are this represents the relation R1, R2, R3, Rn, and P represents the predicate, right? So resultant SQL is a relation. So that means you work with a set of relations or tables, extracts a set of attributes out of it by applying some predicate P, but the end thing is also a relation. Right? So you end up in another set of relations in the thing. Okay. So the select clause. So this is a general structure and supported by across the different vendors, right? So select clause lists the attribute desired at the resultant output. So I can have select say instructor name and the course ID and the particular semester, right? And by having relation both the instructor and the course ID, right? So and then that while the selection is there, it only that output relation or the output table is the instructor name and the course ID, or maybe instructor ID, instructor name, course ID, and things like that, right? So or different. So if there are only two relations, if there are multiple relations, then we can go for other type of things. So corresponds to the projection operation to the relational algebra. So if you see that it is so if I only have like select name from instructor, only one relation. So what it is doing, it is basically just projecting the or taking out this name column from the instructor relation, which was there, and it prints that here the which is non-null, and it prints the list of names. The SQL names are case insensitive, so you may have uppercase or lower. Okay, so in case of things that it is whether it is caps name or small name or things, it is right. So so this basically if you look at our relational algebra term, so it is the projection. So I am projecting or extracting that column. If there are multiple relations which are in the from clause, so I basically do some sort of a joining those by using Cartesian product and then extract that. So similarly, SQL allows duplicate relation as well as query in the query result. So several implementation of the SQL allows duplicate relations. So by default, if there are two instructor with the same name but different instructor ID, but if you see that take out only the name, so it will result to a set of a attribute of the column having set of names, right? So where there may be repetition of the things. Specifically, if I say that from the instructor table, so there can be in the instructor table there are instructor, what department they belong to, their ID, salary, etc. Now, if I extract that is department name from the instructor table or the instructor relation, so there may be repetition of the thing. So there may be several computer science, several other department things will be there, right? So by default, the SQL should have only one instances, right? So it is some sort of a set theoretic representation. So one instance will be there. But there may be SQL implementation which allows duplicates in the relation as well as the query results, right? In that case, you will have more than one instance of the department if there are several instructors from the same department, right? So there is a construct called distinct. So it enforces that only the distinct values of that particular column are displayed. So the key word all specifies the duplicate, and so there is a distinct is there, and so all duplicates are removed. But if I use the keyword all, then it says that the duplicates should not be removed, right? So all duplicates should be specified. So if you are not aware of that how things are implemented in that particular system what you are using, so it is better to use that. If you want the distinct value, use distinct, or use if you want the all the values, use the duplicate use the all uh, keyword into it. So select all department name from instructor, select distinct department name from instructor, right? So if we have a asterisk like select star from instructor, so it will display whatever they are in the instructor. So it is something print instructor table. So if you want to print the instructor table, then we can say select star from instructor. Print students table, select star from student. So all will be printed. Right? So it is a, as it specified, it's a wildcard. So an attribute can be literal with no from clause. I can say select 437 result in a table with one column and single row with 437. So I can create a relation like this, right? A table like this with 437. Can give column name using thing as foo, right? So we create that and then give something foo or something random and anything you can give. So an attribute can be literal from the from clause. So I can select A from instructor result in a table of one column of n rows, but the values everything is a it will be A, right? So when we use this form instructor, it takes that the number of rows in that column, but as you have not specified anything or from the instructor table, so and instead we have specified quote unquote A, so it will be within the single quote A. So of this n rows of the corresponding to the number of rows in the instructor table, a column will be created with all A's. Okay. So, so that is the right. So rather, we can have other things like select clause can contain arithmetic expression also, right? Like in this, like plus, minus, star, slash, and operating on constants or attributes of the tuples, like query select ID name 12 salary by 12 from instructor would return a relation that is same as the instructor relation, except that the value of the attribute salary is divided by the 12. So it can be, it will show that if it is a, as if in the instructor table, the salary represents the yearly salary. So in the this salary table, sorry, in this particular output of this query, so it will create that ID, name of the instructor, and salary by 12, or in other sense, it effectively the monthly salary of the things. So if we want to change the name of the column, so instead we can say that rename salary slash 12 as monthly salary. So the column name will be ID, name, monthly salary, right? Under that, this instructor ID, instructor name, and monthly salary will be printed. So there is a where clause specify the condition that the result must satisfy corresponding to the selection predicate of the relation algebra. So if you remember the selection predicate, where clause basically condition by which must this specifies the condition, right? So to find the instructor in the computer science department, select name from instructor where department name equal to computer science. Right. So department name equal to com science. So select name. So what we do? So select those tuples where the department name equal to is the computer science in the instructor table. Right. So comparison results can be combined using the logical operations. We can say that like in this case department name this and salary and this, or I can say department name equal to computer science or department name equal to say electrical. Those type of things can be all those logical operations can be done in the where clause. So where basically the predicate you want to use. Right? So comparison can be applied to the results of the arithmetic expression also. So when we use this from clause, the from clause lists the relation involved in the query. So correspond to the Cartesian product operation in the relational algebra. Find the Cartesian product instruction like select star from instructor and teaches. So it generates all possible pairs of this instructor teaches pairs, right? With all attributes from the both the tables, right? So for common attributes like the ID, it will be instructor.id type of thing. So that is a table name dot the ID if they are the common attribute, right? For the distinct attribute, it will be in the same way. So the attribute of the resulting table are named using the relation name called instructor.id and the Cartesian products are not very useful directly, but useful combined with the where clause conditions, selection operations, and relations. So you may not be find much usefulness of these things only the Cartesian product, but when you combine with the other things like where clause and things like that, then it will be. So if I the instructor and the teachers, so we have this sort of a Cartesian product when we have this type of clause called select star from instructor comma teachers. Okay. So there are example find all names of the instructor who have taught some courses in the course side and their course ID. Right? So what we are trying to find the name and the course ID is from table instructor and teachers where instructor.id equal to teachers.id. Okay. So the from instructor and teachers. Right? Find the names of all instructor in the art department who have taught some course and the course ID. Right? The select name from this. So instructor teaches. So instructor ID equal to teachers ID and instructor department name equal to R. Right? So this type of things, this sort of things, some of the things you have already used in your this assignment in the lab. We can have different type of clauses. Similarly, there is a concept of renaming. So when specially required, when we are doing something, select the same table or joining, self-joining sort of thing. So what we do, find the names of the instructor who have higher salary than some instructor in the computer science. Right? So what we are trying to do, we are to find out the names of all instructors who have a higher salary than at least some instructor in the computer science. So in order to have that, we need to join this or make a Cartesian product of this instructor relation with the instructor relation itself. Okay. So what we have this so what we, in order to make that and then I have to compare based on this predicate like greater than salary and things like that, right? And also the department name as the computer science. So for that there is a rename operations, like we can say instructor as T, instructor as S, right? I can very well do here also instructor as T and instructor as say I and teaches as T, and then instead of instructor.id teaches.id, I can say I.id and T.id, I dot department name equal to R. So those things are that is naming is nothing to do per se with you have to use that same relations multiple times, right? So T dot salary is greater than H dot salary and S dot department name equal to com science. Right? So what it tries to do, it basically extract those tuples which are having com science and then compare those cases, basically extract those cases where the T dot salary is the S dot, those tuples where T dot salary is greater than the S dot salary. Then there may be repetition of the same thing. Suppose the higher salary person will have that in number of cases. So what we did then, when we want to print only one that name, so we can say that select distinct T name. That means there is no repetition of those things which are if there are in the output thing, because here we are only taking the T name as the your projected output or the in the output schema, output table or relation, right? The keyword as is optional, right? So if I say instructor blank T or instructor blank S or something in the previous thing, anything blank S, so it is by default it is equivalent to instructor as T, right? Instructor blank T is equivalent to instructor as T. Okay. So self join example, and like we have person and supervisor, find the supervisor of B Bob and find the supervisor and supervisors of Bob, supervisor of Bob. So and find all supervisors direct or indirect of the Bob. So we can have this sort of things which are which requires a self joining of the relation with itself, right? While dealing with string, there are some special features which need to be looked into. So SQL includes string matching operator for comparison of the character string, right? The operator like uses the pattern that are described using the two characters, right? So one is percentage matches any substring, and underscore the underscore character matches any character, right? So like here we want to find those instructor, right? Name of those instructor whose names includes the substring DAR, right? So it is percentage dar percentage. So name like dar percentage dar percentage, right? If you want that the should have a DAR at the end, then we can have percentage dar only, DAR only, right? So matching string say 100%. Right. So now if there is a percentage, then we have to use a escape character like you have already done in other type of languages while writing things, that if you want to use the special character, so you have to give \/ then percentage. Right. So above, in the above we use \/ as the escape character. So here in case of string, these patterns are case sensitive. Patterns matching example like intro percentage matches all string beginning with intro, that is intuitive. Percentage com percentage matches any string containing com. The words COMP with capital C as in caps. So 3 underscore matches any string exactly 3 character. 3 underscore percentage matches any string of at least three characters. Like it should have at least three characters and then anything. Right? So SQL supports a variety of string operations like concatenation, converting uppercase to lowercase, finding string length, and etc. That you will see, and that you can refer any standard book or literature. Okay, so just we'll have this slide and we'll stop for today. So list in alphabetic order, there is a ordering of the thing. So select distinct name from instructor, order by name. So we specify either we can specify DASC for descending. Ascending by ASC is by ascending order is by default. For each attribute, ascending order is by default. So order by name DESC, so it is by descending, and can sort or multiple over multiple attributes. Order by department name by and name. So it sort by multiple things. So it initially sort by name and then goes for the using by sorting by department name and then by the name. Right. So there are different things for it is construct for ordering. So in the tomorrow's class, also we'll see few more such construct, the basic SQL, and then we'll slowly go to the slowly go to the more intermediate and advanced concept of SQL. So so let me stop here. So if you have any question or query, you can come. Otherwise, only again I announce now just to remind you. So tomorrow at beginning of the class at 10 o'clock we'll have that have your quiz, right? So in PSC movie. But anyway, you join. You need to join the PGMS class in MS Teams also, and then start with your Moodle server. So please check if you have login. Just cross check that login password thing so that there is no hiccups at the during the test. We'll have test for 15 minutes. Okay, so let me stop the recording.